All right, good morning and happy Wednesday, my elite code problem solving friends. Today I'll plan on doing the daily challenge. So here we go. Sheath. Ooh, Koko eating bananas. Okay. Yeah, so this one we can actually do binary search, right? That is, we perform a logarithmic amount of guesses, cost a runtime cost of a linear scan. Linear scan for validation. Yeah, that makes sense. Okay, so it is 5:19 a.m. This is our game plan. Okay, let's see what happens here. I've got my coffee, I got my game plan, so here we go. You want to eat them all. Okay, right. So, example one, pretty sure this will work, right? I'll just go through these examples real quick. 3, 6, 7, and 11. Cakes 8. 0, 1, 2, 3, 4. So n equals 4. N is the cardinality of the input array A. So you eat K. Oh, K is the eating speed. I just won't like this thing. The input T is our threshold for hours. Now let T, input T. Right, so basically, yeah, we're gonna guess K given input array A and threshold T. Right. I guess for K, which would be somewhere between I and J, I would be the smallest of those. So what's the maximum time it could take then, or what's the maximum K? I mean, 9 is like, I know, 1 billion. So if it has less than K bananas, you eat them all. Otherwise, you'll eat K at a time. Eat. So it's the maximum X divided by K. Time to eat all of the array, the input array, oops, is the maximum of X divided by K. how much time it takes to each pile for X and A, right? Where X is the quantity of bananas in the pile. So make OK, K will be our guess, and we'll just binary search this guy. So let's see. Yeah, go OK is a lambda K, and return the max X divided by K for X and A. Or it's less than or equal to T, which is our time threshold, while I is less than J. K is I plus J divided by 2. Oops. If K is okay, then we have more time to, or let's see, K is big. We want the smallest K. All right, so J equals K. If it's not okay, then I equals K plus 1. Okay, let's see what happens here. For, 2 is what we're saying is okay. Oh, it's per hour. Won't eat anymore. So each pile oops, okay, so I didn't add this up right. So we need 4 eating speed of 4. So eat 4. Right, plus 1. We'll eat the first pile. We'll eat this guy. Okay. Yeah, so my validation is somewhat off, right? 2. Right, that guy goes to 0. This guy's partially eaten. Right, so it goes to 2. Right, I think this looks. I understand the problem, right? I think so. Eat the rest of this guy. Eat 4 of those guys. Eat the rest of those guys. Eat 4 of those guys. Right, yes, that works out. 7, eat 4 more of those guys. Oops, 3 left. And that 8, all of them are eaten. Okay. Okay, so we want to consume them in chunks. Right, so let's modify this slightly. Actually, let's keep track of this. It's 5:27 right now. Okay, so it's about 8 minutes for incorrect solution. Linear validation is wrong, right? Okay. 5:27. Fix this thing up. Okay, so T is what we'll return. Less than or equal to our threshold T, then it's true. So for many trips each does it take? Wait a sec. Let me just comment this out just to keep track of my breadcrumbs. One. Oh, the sum, right? It's the sum, the accumulated sum of these. Right? 1, 2, 3, 4, 5, 6, 7, 8. And it needs to be the ceiling of this guy. Okay, so that looks right. Oh, okay. Gotta subscribe and pay to have that kind of fast action. Okay, this looks cool. Looks like I saw this about a year ago. Uh-oh. Divide by 0. Oop. Okay. Oh. Okay, we don't want k to be 0. We have to eat at least 1. Oops. Okay. Let's see. 529. Use some instead of max validation. Okay, and then this one is incorrect solution. Divide by 0. Okay, so I has to be at least 1. Okay, let's see what happens here. Yay! Okay, accepted at 5:30. 5:30 in the AM. So we started at 5:19. 5:19 to 5:30. That took about 11 minutes. And that was with plus 1 bug. Plus 1 bug. Okay, that's not too shabby. So yeah, it looks like I solved this 2020 and 2022, now 2023. So that's cool. All right. Let's see what I came up with the other solutions here. I did a linear scan, really? Oh, okay. I was like, no way. A linear scan is gonna TLE, right? Okay. Instead of F, I think it makes more sense to call this thing okay, but T, yeah, and then return this guy is less than or equal to T in here. Yeah, so my current solution, I think is better than my old solution. Might as well post it, right? It's a little easier to read. Like okay is pretty obvious whether if it's okay or not. If it is okay, then we know k is sufficiently large. If it's not okay, then we know I is insufficiently large, right? So we turn the smallest I this way. Okay, so this is kind of noisy, right? Who cares about brute force? Um, make a logarithmic amount of guesses for k at a runtime cost of a of n a linear scan for validation per guess. Right, this is binary search. All right, Kotlin, JavaScript, Python 3, Rust, and C++. Okay, let's just jam this out real quick, clean it up a little bit. Okay is a self-documented validation. All right. Maybe I should describe this, right? Right, it's okay. A case yes is okay if and only if the accumulated sum of each value x of the input array A the ceiling is less than or equal to the threshold t. Right? The time it takes to eat each pile x of bananas, right? Yeah, it's okay. Right? It's pretty straightforward. Right? I don't need to explain it too much more. Read the problem statement, right? If you need more information, that'd be perfect. And I don't need to spoon feed. Threshold. Okay. Is gas. So I'm going to divide by 0. 9. Return I at the end here. Return accumulate. Again. Oops. 8 end. And we want to take in A by reference. Take in K by value. I'm going total will be T plus the ceiling of X divided by K. So less than or equal to our threshold T. Stick that up there. All I is less than J. E is I plus J divided by 2. Oops. If K is okay, then we'll shrink up J. Otherwise, if it's not okay, then I is invalid. And we'll increment that by 1. Uh-oh. 3. Oh, oops, this needs to be a double. Right, so we can round up. X. Okay, that looks good. Okay, that's cool. Nothing too fancy, right? Okay. JavaScript. Input array or threshold T. Okay. Okay, it's the input. Actually, let's do this. Use low dash sum. Make sure it's less than or equal to our threshold t of each value a. Map it x divided by k, and take the ceiling of that. Sum of the ceiling of all those, let's try to t, and then let ij equal 1 and 9. All i's less than j. Turn I into here. Oops, k equals 4 5 plus j divided by 2. If k is okay, j equals k, otherwise I equals k plus, plus 1. Looks good. Okay, that's cool. All right, Kotlin, and then we'll do Rust and, oops, let's do Kotlin next. This guy, there's our threshold. Our okay is the lambda. K is our integer for our guess. Right, so e dot map it dot to double divided by k dot to, or actually just k. Yeah, it's okay. Sorry, I'll just call it a double. Okay, just call it a double here, and then do the ceiling of that double divided by that double. Oop. The sum of that is less than or equal to our threshold t. And j are a pair of 1 and 1 e9 dot 2 int. While I is less than j. Turn I in the int here. K is math of, oh, actually, I don't need that. That's j divided by 2. If k is okay, then j equals k. Otherwise, I equals k plus 1. I think that looks good. Okay, that's cool. And then saving the best for last, we'll do Rust. That's the best for last, or the most difficult for last, but here we go. Vector of I32s. Shorten that up just a little bit. Okay. That's okay. Equals input k, and then do a dot iter dot map each value x, which is borrowed, stealing, I need to look at that up. Seal. Let's see what we have here. Yeah, I want to mem.seal. All right. Sealing of that. Accumulate it as a sum. The threshold t. X as I or float, right? Divided by k as a float. ceiling of that. Okay, so that's okay. And then let mute I, mute j, equal 1 and 1e9 as I32. Return I at the end here while I is less than j. K equal I plus j divided by 2. If OK, K, then j is K, otherwise I equals K plus 1. Okay, let's see what happens here. Okay, the object and the location of X since it's borrowed. Uh-oh. Some, oh, as I32, right? Is I32, or I don't know if this needs this or not. Let's see what happens. Okay, that looks good. Uh-oh. Output's not big enough. Oh, okay, let's do F64. This divided by that as I32. Okay, that looks good. All right, +1 bug from Rust. Okay, so that's cool. And then do I need to cast this thing like that? I don't know. Let's see what happens. Ceiling should be an integer, isn't it? Okay, I do need to cast it. Okay, fine. That works. Okay, and that's all she wrote. Right, binary search, make a logarithmic amount of guesses for a k at a runtime cost of O of n for a linear scan. That doesn't sound right. Right, I think that works. Right. Make a logarithmic amount of guesses for k at a runtime cost of a linear scan for validation per guess. A kth guess is okay if and only if the accumulated sum of each value, the ceiling of x divided by k, for each pile, or each x bananas, the input array A, right? I think that makes sense, right? Binary search, you make a logarithmic amount of guesses for a k at a runtime cost of a linear scan for validation per guess. That is, the kth guess is if okay, if and only if the accumulated sum of each value ceiling of x divided by k for each pile of x bananas, the input array A is less than or equal to the threshold t. That sounds good, right? And it's self-documented code, like, is it okay? Right, that's pretty obvious. Right, okay, cool. Catch you all next time.